Okay, let me know if you're not able to see anything on your screen. I'm showing my PowerPoint slide now. So again, for learning outcome for this module, you're going to learn 5 things. The first one is the control volume method, we will cover today, and losses, lift and drag, and then we're going to use some ANSYS software to solve for your problem in the assignment. And then we're going to look at pump and turbine. All right, today we're going to look at, and then for your assessment, 40-60, make sure you understand the distribution of your marks. All right, so we already clear for our fluid mechanics last 2 weeks. Then today we're going to look at chapter 2, finite control volume analysis. Okay, now under chapter 2, we have a few components. We're going to look at a few equations. So the first one is continuity equation. Then we're going to look at momentum equation. Momentum, there are 2, linear and momentum, but you can call them as a momentum equation. And you look at how is the derivation and application, and one more, energy equation. So we have a continuity equation, momentum equation, energy equation, and then we go and look at how Bernoulli equation that you learned in the fluid introduction to fluid link with the energy equation. So we're going to look at the first one. Okay, we start with our tutorial question number 1. It will ask you about FCV. What is FCV? FCV stands for finite control volume analysis. Finite control volume analysis. Now, by its name itself, means that we control the volume. When we analyze a question or problems, we focus on, we'll draw out the boundary layer, we'll draw out one area with specific for our problems, right? We will define that area as a volume. Then we focus on that volume. The keyword is volume. The keyword is volume, and then this analysis method is using the four approach that you see on the screen. There are 4. First, conservation of mass, meaning there's no change of mass. You have to understand that when you study flow or you study fluid mechanics, when you draw a volume, let's say you draw a box, they must, and the flow is flowing, the flow is flowing. Let's say the flow is flowing from the left to right. Let me try to draw something on the screen. So let's say you have a volume, right? Let's say we look at 3D condition. And the flow is flowing from the left to right, okay? From the left to, coming in from the left, going out to the right. And the axis, in fluid mechanics, every time when you solve question, be sure to look at the reference axis. So normally X will be to the left, to the right, Y will going up, and Z will coming up from the screen, or you will go to perpendicular to your XY plane. Okay, so this is the basic diagram that normally we will draw when you solve question. So conservation of mass means that the mass going in from the left hand side, when it come out, it will be the same. So or you can say that there's no changes of mass inside the volume that you draw in for the problems. Okay, you contain the volume, and then you study what happened inside this red color box. All right, so the mass won't be changing. This is the first idea that we are going to use to analyze the fluid mechanics problem. All right, the mass. The first one, you look at the mass. No mass is changing. Then the second one is Newton's second law of motion. Okay, so this one, if you study Newton law, you know that Newton law have 3. So the second one is the famous one, F equal to ma. So just to go back to the previous one, conservation of mass means that mathematically you write sum of mass will be 0 for the system. Second one, if you want to memorize for your revision, for second one, Newton's second law for fluid control volume analysis, you remember F equal to ma. Okay, F equal to ma. And then the third approach, we're going to use thermodynamics law that you learn in thermodynamics. It will deal with the word thermodynamics. It will deal with energy. Okay, energy. The keyword for the third equation is energy. So energy, you deal with internal and external. We'll look in detail later on. But for these slides, what is I need your attention is pay to the keyword every time you look at the analysis. And another one is approximation. Right? Approximation means you'll be given a boundary layer and a certain value. You straight away use the value given, approximate. Or sometimes we can cancel. We can assume, we'll use assumption. Let's say you assume something. Then you can cancel some parameter inside the equation. Okay. So for today, the first slides, to solve for control volume analysis, you have 4 methods with when it comes to your final exam. You might be asked to use either 2 of this method to solve. So either you'll be using conservation of mass to solve the problem and then match with maybe second Newton law and then compare your answer. Is there any changes? Or maybe you'll be asked to solve using approximation method, something like that. Okay, so for the first slides for today, recall that you need to use conservation of mass. When you see the word conservation of mass, means there's no changes of masses inside the system, inside the box. Second Newton law, F equal to ma. Ma means M means for mass, A acceleration. Okay, and acceleration is the rate of change of your velocity. You take your velocity, divide by t. And maybe for this chapter, you need to recall what is differentiation. When you differentiate your velocity towards time, dv dt, you will get acceleration. This is what you learn in your advanced mathematics or physics class when you learn about momentum. All right. So when you want to define your acceleration, you need to recall differentiation by using dv over dt to get the acceleration. All right. And so on. Okay. Let's see. So on my slides, I give you some points to memorize. So conservation of mass, in equal to out, right? Or all the mass equal to 0. Second one, F equal to ma. All right. Deal with second Newton law will use to derive the force, the moment, and the torque. The word torque, you have to recall what is torque or moment. So if you learn about physics, again, what is moment? Let's say you have a reference point. This is a surface. And there's a force that is go along the surface. And the distance is perpendicular to the surface. This is your d, distance from the surface. And this distance is perpendicular to the reference point. And the forces, the action of the force and the d on this point will give you torque. Will give you torque in a clockwise direction. This is called moment that you learned in your physics, or torque. Another word for moment is called torque. Apologize for my writing. All right. So you need to recall all these fundamental physics. And from the force and moment, or force to torque, you can convert them to work and power. Okay, this one we'll look at force converted to torque in the last chapter of this module, where when we look at pump and turbine. So the force will convert to work and power. Okay. So we have covered conservation of mass. We cover second Newton law. The third one, thermodynamics, is more on the energy, conservation of energy. So we'll look into it later on. We will look at the forces, losses, and so on. Okay, so these are the four main ideas for this chapter. Okay, so when we talk about control volume, you need to be pay a bit more attention which stage that we are discussing. All right, so we'll go for 4 stages if you follow along. So we'll go for conservation of mass. Then after that, we will look at the same FCV problems, but using second Newton law equation. And then we will followed by the third method or third approach by using thermodynamics law. And maybe the last one will be using approximate approach for FCV. So for control volume analysis, you have 4 methods to solve problems. Okay, now we look at, for today, we only look at continuity equation. The word continuity, it means that it means about mass. The keyword is mass, the M. All right. So what is going in must be same like going out. So conservation of mass is state. Since there is no change of mass, we use time to gauge or to calculate or to define this principle. Okay, the time rate change of system equals 0. So mathematically, you should know how to write dm, the change of mass, divided by time. You will get time rate of change of system mass. So system mass, we use capital M subsystem, right? So when you write d, just to let you know that for fluid mechanics, you have a few differentiation. You have d something over d. You have d something over dt. You have a capital D, small d. You have a delta over delta t. Delta something. Let's say I use m. Mass. All of this. And then there's you will see this one, partial differential mass over dt over del t also. All right. You have a few presentation of symbol when you talk about changes of something. In this case, I'll use mass. So when you look at capital D or small d, or even delta symbol, it means that something that you can measure. Something that you can measure either with your weight or with your machine, right? Or ruler, something that you can measure, then you use d delta. But if you see something that is very, very small changes, right? Very, very small changes, and every time you see a delta form like that, we call it partial differential symbol. It means that the changes is very, very small, maybe up to a molecular level. Means it's very hard to measure, but mathematically the changes is happening. Okay, So take note on the notation that we're using. All right. So just as a starter, we are use D form, D over dt something. It means the changes over time or over mass, something like that. Okay. So first mathematics, when we talk about conservation of mass, you have to recall this equation. So this one will give you 1 mark. If the question asks you to solve using conservation of mass principle, the first equation on your answer sheet, we are expecting you write d over dm over dt equals 0 just to show that you understand what is definition of conservation of mass principle. You write somewhere in your answer sheet for that particular question, you get 1 mark before you solve. All right. So far, we're still at the conservation of mass principle. Next, you need to recall integration. When you want to get the overall mass for that system, let's say you have a cube and you look at the cube system, you want to know what is the total mass inside this system. Inside this system, then you do integration of this equation. Right? So how to do integration? You pull d to one side, d to another side. So this one, you pull to another side. Okay, this one you pull another side. Then you do integration. Okay, integration. So we will, using mass, we will use another 2 parameter. How do you get mass? So when you study about float, normally you begin density times volume. If you see something I put in the middle like that, it means volume. Okay. So I'll draw a bracket just to represent the unit. The density unit will be, okay, let's test. See who is in the class. Yong, are you there, Yong? Yong, are you there? Okay, your mic is not working, Yong. Yong, can you turn on your mic? Okay, never mind. Cool.
Yes, sir.
Okay, cool. Give me the unit of density. What is rho? Unit? Unit SI? What is the rho? What is density unit?
Density unit. N over V.
What is a unit? For example, time. What is the time unit when you use to define time?
Second.
You use second, right?
Yeah, second.
So rho, you use what?
Rho, we use mass per second, right?
Yeah, what is the unit? You're saying mass.
Okay.
I'm asking about unit.
Unit.
I'm not talking, for example, time. Unit is second.
Meter cube.
Mass over what? Let's say, you say mass over what?
Or mass over volume.
Volume.
Yeah.
Okay, so what is the mass unit? What is the
Mass
How you define mass?
Uh,
How you weight it or how you measure it?
kg.
Kg. Volume?
Meters square.
Meter square.
Cube. Sorry.
Okay. Kilogram. Meter cube. Volume. Meter cube. You time these two method. Okay. Thanks, Aku.
Yeah.
All right. So when you cancel the unit, you'll get kilogram. Okay. So this is the dimensionless analysis, which you will learn later. But I think you learn about this one in your physics also. During your secondary school, you learn to cancel out the unit. Okay. So far, two differential equation, two equation for mathematics that you need to recall. Differential, integration. So to get a rate of change of your mass, you use dm over dt. To get the total mass of the system, you integrate rho over dv. Okay. So how do we use these two definition in the finite volume analysis? So the first assumption that you can see on your screen, the first assumption, we assume that the system is fixed and not deforming. Means that our control volume is not changing shape. For this module, in this chapter, you will look at two scenarios. One is non-deforming, one is deforming. Okay, so we look at the first category, our first scenario, where our control volume, let's say I'll draw it in the box. We call it control volume because it's a study area that we define. It's not necessary as a square. It can be prisma. Now, prisma is always used in simulation like ANSYS, SolidWorks, and AutoCAD simulation. So this is a control volume used by the software. It can be sphere also. All right, it can be a sphere as control volume. What else? So, but anyway, for simplicity, I will use a cube to illustrate the idea. All right. Okay. This is for question number 2 in your tutorial. When it asks you to derive the continuity equation for a non-deforming control volume, you will start using the conservation of mass equation. So what does it mean? Let's say you look at the diagram on the left-hand side. Let's say you have a system with this system means the problem that you are going to analyze. So let's say you're having a problem or a system that defined by a blue solid line, and you start drawing the control volume for this module. When you have a diagram, you need to scratch your control volume, which is represented by the purple color or the pink color. All right, lines, dashed line here. So, and this control volume will follow the shape of the system, right? So you define as the control volume. So first idea, when you need to define the control volume, you will always follow the system shape, and then you use your pencil or you use your pen to use a dotted line or dashed line to copy the shape. And then you draw an arrow to mark as a control volume. So in your test or exam, if the question asks you to solve using a control volume approach, then in your answer, you draw the control volume like this. You draw the dashed line, you draw an arrow, you write control volume, you'll get 1 mark for this you will get 1 mark for this effort. You'll get 1 mark for drawing the line and write control volume. Okay, then the second one, you look at this tree diagram on the left, middle, and right. What is their differences? Is that it's showing the movement of your system. Okay, it shows the movement of the system. As you can see, the control volume doesn't move. The control volume doesn't move means that you fix your camera or you fix your eyes to that particular system, to that particular position, and then your system will moving through the control volume. All right. So the first idea, when you talk about control volume, you draw the line and make sure the line doesn't move. All right. You fix to that particular position, and then you study what is happening inside the control volume. Okay. So for the middle diagram here, after you draw control volume, let me use the red color. Never mind. Okay, this is the first step. You draw control volume. Second, you draw the second. You put in numbers that represent the input and output point. First, you draw the control volume. Second, you draw the input and output. You mark on your answer or in your diagram. One, normally you represent input. Inlet, we call it inlet or input. Inlet. Number 2 here represent output. First step, second step, third step. Then the third parameter that we're looking at is your velocity. Velocity will always start from inlet and then come out to outlet. So this is number 4. Step number 4. Step number 5. Okay, so just follow these steps and you manage to find the answer. First, you draw the control volume to define where you want to study. After that, in the control volume, you label where is the inlet, where is the outlet. Next, you put in the velocity going in and velocity going out. Okay, velocity in, velocity out. Okay, same when you do simulation using ANSYS or using other fluid mechanics simulation. You still need to define your domain, computation domain, or in this case, we call it control volume. And then you need to define where is your inlet, where is your outlet, and then the vector of your input. For example, in this case, you have velocity input on the left-hand side, velocity input for output for the point number 2. Okay, clear everyone so far? What you need to write on your answer every time when you come to test for control volume analysis, especially using conservation of mass. The first equation that you must come to mind is dm over dt. Second, integration to get the total mass is integration of rho times integration rho dv. This is volume, rho dv. Okay, look for rho. Look for where is your control volume, dv. Then the next one, you draft the sketch out the problems that given in the question. First step, you go for control volume. You draw the control volume with your pencil or with your pen. Then after that, you label input output, followed by your velocity input, velocity output. Okay. All right. So far clear? Everyone clear about the steps when we want to derive the continuity equation? Clear? No question, eh? Make sure you understand now. Important that you understand what is happening on the screen. Okay, and move forward. So one very important time frame that we need to focus is where your system clash, or you can say co-incline, coincident with the control volume that you draw. Okay, it match together with the system and control volume. Then from here we derive the equation. So just mathematically, just to recap, what happened is before we use negative sign, negative delta t, and you can see the delta form here. Delta, just now I mentioned about the three form of the changes of something. So if you see this delta, it means it changed in a very, very small dimension, partial differential dimension. All right. And if you define something mathematically about an incident after it happened, we use positive sign. Okay. So this time frame will give you the motion location, whether it is after or before. Okay, we still at a very basic idea on continuity equation. We have covered how to draft the control volume. We have covered the two equation, continuity equation, dm over dt equals 0. Yeah. Let's say I just want to help you to score some marks. I will ask you to define conservation of mass mathematically. You write this one. Dm over dt equals 0. Straight away you get 2 to, yeah, normally it's 2 marks, right? 1 to 2 marks. Just in case there's a question I set to help you to score some marks. So just keep the opportunity to take the opportunity to score some marks. All right. Then the rest, this one you will write many times in your answer, right? You'll be using the integration to get the mass at the end. Okay, let's continue with the derivation steps. We're going to use a mathematics approach also. We call it theorem, and this theorem is Reynolds transport theorem. Reynolds transport theorem. Reynolds always deal with the flow, molecular flow, of air flow, or fluid flow. Something that flow, then you will see this Reynolds name. What does this theorem tell us? A very important equation throughout this semester for this module. You can say that this equation will always help you to score 1 to 2 marks every time you write this equation in your answer sheet. Okay, so start from today, try to memorize this equation. This equation will expected from you in test and exam. All right, and this equation won't be given, and you need to use this equation to solve. This equation is called Reynolds transport theorem, that give you three component. So today your homework is to memorize this equation. The previous one is you just recall what you learned from the physics, but from this module, today I want you to memorize this equation. D over dt integrates of your system dv. Again, Ku, are you there, Ku?
Yes, sir.
Cool. This component, integration of system, rho dv, what do you get? When you take rho times volume, what do you get?
Kg.
Yeah, okay. Kg what? Kg is what? I'm not asking you about unit. I'm asking you about what is the thing that you get when you, what is the product when you take density times volume? What product you get?
Mass.
Mass, correct. Okay. Okay, I'm going to ask Shirley. Shirley, this question is for you. When you take mass, the mass divided by dt, what do you get? When
You
get,
mean what?
yeah. Oh, what can you define when you take the mass divided by dt? When it's equal 0, it is what principle you learn, or what is the what principle you learn, or what is the law that you learn?
That one is conservation of mass principle.
Correct. Okay, the m over dt is conservation of mass. We are at conservation of mass. So always check you understand what is the component for the question. So the question will sometimes ask, okay, use conservation of mass means you straight away you write this equation with conservation of mass on the left hand side, right? If you use conservation of mass or continuity equation, the whole thing will equal 0. Means these two components you add up, you get 0. You are actually defining using continuity equation or conservation of mass. Okay, the next one I'm going to ask next person. Okay, next person will be Raj. Are you there, Raj?
Yes, sir.
Okay, Raj, you look at your screen. I'm going to ask you. Okay, never mind. I'll ask you later because I haven't teach you this. Right. Raj, later I will ask you. Just pay attention. Next question will be you.
Okay.
All right. So on the left hand side, we already mentioned more than 2 times that on the left you can define, you can use to define the conservation of mass, or dm over dt. On the right hand side, we look at 2 dimension. One is CV dimension. What is CV? Is look at control volume dimension. Another one, we look at control surface dimension. Okay, so today we're going to teach you what is these 2 component. Okay, first important equation is conservation of mass, and the one that you see on the screen here, make sure today you memorize this one, right? It will help you to score at least 2 marks in final exam. At least 2, at least 2 marks. If you write this one out, you will get at least 2 marks for this equation. All right. Okay, just pay a little bit attention on the differences between these 2 terms. There's a difference between the control volume and the control surfaces. If you look at control volume, you take rho times dv, means rho times volume. Again, you get mass. Mass divided by T, you get mass flow rate that go through control volume. Okay, just to help you to memorize this idea. This is dm, because rho times volume, you get mass divided by, sorry, maybe I use del form. Apologize for my mouse cursor. dm dt, maybe in other module you see this symbol before. M dot is the mass flow rate. Okay, mass flow rate for control volume. Always link mass flow rate with control volume. The second term is control surface. Now, what I mean by control surface? If you draw a cube, maybe I draw it here. Let's say you have a cube like this. All right. Now, volume, you know that is, you know how to calculate volume, right? Volume is this one. However, when you look at control surface, you look at the surfaces area, A here. Okay. Raj, just a simple question. How many faces you have for a cube? How many faces you have for a cube?
6, sir.
6. So for control volume, you will have 6 faces because you will integrate all the area that that you focus on. So just be clear. For this module, you have 3-dimensional cases. You have 2-dimensional cases, right? So be careful when it comes to a dimension. So yeah. So later I'll stress again. What is important for this equation today? The most important equation for today is you memorize what is conservation of mass equation, and when you want to derive or want to solve using a non-deforming control volume, you will use these 2 components. You focus on what happening inside the volume and what is happening to the control surface. Normally, control surface, we will look at in and out. In and out. All right. So if the volume, let me change the color of my pen. If your mass go into these surfaces and only come out at one surfaces here, meaning you only focus on in and out, meaning 2 surfaces you need to consider. However, if you pump in from one side and the mass come out in 2 directions, let's say the mass come out to the y direction and x direction, these 2 surfaces, meaning you need to consider for control surface here, you'll consider the y component and x component. Okay, so and so on. If the flow, you need to be careful on the outlet. You need to study how the flow come out. Most of the time, it will be a simple case where you can imagine through the opening of the pipe or for the duct. Okay. So later I'll speak more on that. Important. Your equation consists of 2 dimensions or two components. One is volume, one is the surface. Okay, let's continue. All right. Now we're going a bit deeper. Maybe we stop here and then we go for a short break. We will continue on how we derive this equation. Okay, how we use diagram to help us to derive this equation. Okay, let me stop the recording.